Hi, welcome to this tutorial which is on indices or powers or exponents. It's an introduction. There will be a series of tutorials on indices to come. Let's consider something like 2 times 2 times 2 times 2. We would write this as 2 with a little 4 on the top right hand corner, and we would read this as 2 to the power of 4. Don't think it's 2 times 4, which is 8. 2 times 2 is 4 times 2 is 8 times 2 is 16. So there is a difference between them. This little 4 is called the exponent or power or index. Well, what about something like 3 times 3? We will write it as 3 to the power of 2. And we would read it as 3 squared. So when it's a power of 2, we say squared. 3 times 3 is 9. If you think it's 3 times 2, which is incorrect, 3 times 2 is 6. So it's not to be confused with that. Let's then look at 4 times 4 times 4, which would write as 4 to the power of 3. And when it's a power of 3, we use the word cubed. So we read it as 4 cubed. 4 times 4 is 16. 4 16s are 64. So don't get it confused and think it's 4 times 3. It's not. 4 times 3 is 12. So what about going now into algebra, saying A times A times A times A times A? How many A's am I multiplying by itself? There are 5 of them, so it's A to the power of 5. That's how you'd read it. Don't get it confused with thinking it's A times 5 or 5 times A. 5 times A or 5A is A plus A plus A plus A plus A plus A. To show the difference between the two, let's put in a value for A. So suppose A is 2. If A is 2, then A to the power of 5 would be 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. If we put it in here, 5 times 2, or 2 plus 2 plus 2 plus 2 plus 2, is 10. So there is a difference between the two. Okay? Now, let's consider something else. Suppose we look at 3a squared. What would it mean? We need to go back and think about BIDMAS. Brackets, indices, division, multiplication, addition, subtraction. So we need to do the indices first before the multiplication. So this would mean that's 3 times a squared. So it's 3 times a times a. Don't think it is the same as 3a all squared. 3a all squared is 3a times 3a. 3 times 3 is 9, and a times a is a squared. So that one is 3a squared, and this one is 9a squared. Again, all we have to do really is put in a value for a, and you'll see the difference. So if a is equal to 2, 3a squared would be 3 times 2 squared. So it's 3 times 2 times 2. 3 times 2 is 6, times 2 is 12. If we do the 3a all squared, the brackets first, bit mass, so it's 3 times 2, and then we square it. 3 times 2 is 6, 6 squared means 6 times 6, which is 36. So there's quite a difference between them. Okay? Well, we can now try to summarize what we've just done. If we have a to the power of n, what does the n tell us to do? Well, first of all, the n is the exponent, and the a is the base. I think of it as a platform. So when I write 2 to the power of 5, I think of that as the platform, so it's the base, and that's the exponent there. So the n tells us to multiply the base, a, by itself, n times. So a to the n is a times a times a times a times a, all the way through n times. Okay? So, what would this 2 cubed mean? 2 cubed means 2 times 2 times 2, which is 8. The base is the 2, and the exponent of power is the 3. The 3 tells me to multiply 2 by itself 3 times. Okay? That's basically a summary. But what happens when you write 5 on its own? What's the power exponent? Well, the answer is 5 to the power of 1. So when there's no power, it's a 1. So if I write x on its own, I'm saying it's x to the power of 1, although we tend not to put in the 1. Okay? So I want to know what the base is and what the power is, or exponent, in the following. Well, this one, the base is the y, and the exponent is the 5. What does the exponent tell us to do? To multiply y by itself 5 times. What about this one here? The base is 5, and the exponent is 3. The exponent tells us to multiply 5 by itself. How many times? 3 times. 5 times 5 is 25. 5 25s is 125. Okay, that's it for now for the introduction. On to the next one. Take care.